Hello, my name is Adam Stein. I'll be your host this morning for the RedShift Shout-Out webinar. We've got a great session today around malicious endpoints, user agents, and media sessions. This is going to be presented by RedShift's Senior Director of Sales Engineering for North America, Tom Fritz. Tom, welcome.
Hey, thanks, Adam. Thank you very much, and I appreciate everyone that's attending. I appreciate your time. Today
awesome.
we're going to
before we get started, Tom. Sorry, Tom. Before we get started, just so everybody knows, there is an interactive Q&A on this. So if you want to chat any messages at us during the session, feel free to on the right-hand side panel. We'll be able to answer those, and we'll probably save a lot of questions to the end. And if you have any problems with the audio or anything like that, just chat at us on the right-hand side using your chat panel. And with that, Tom, I'll push it back to you, and thank you very much for the session today in advance.
All right, sounds good, Adam. Thanks again. Okay, so today's webinar, as Adam pointed out, is the focal point is malicious endpoints, user agents, and media sessions. And we're going to look at this at a fairly high level and discuss just in general what these topics and malicious endpoints, user agents, media sessions, how they affect the SIP voice-based networks. So this case study, we're going to review how the attacking entities are circumventing existing SBC defenses by spoofing certain parameters within the SIP message set, ultimately resulting in toll fraud. And as of 2017, the Communications Fraud Control Association tagged this as a $29.3 billion problem. So from a very high level, what we're going to just describe is just, some terminology. What is an endpoint? An endpoint's either a hard or a soft client that registers for VoIP service on a service provider's network. So they'll either be, a Polycom hard, a hard phone, which is has user agent software in it that would register, or various soft clients that are available out there. So once registered successfully in the network, that endpoint can initiate VoIP calls. Next is, what is a user agent? A user agent is the software used to initiate SIP messages, so such as call control messages like invite, sending option messages, subscribe messages, things like that. A media session it describes the session description for the voice session being established on a per call basis. So this will have the codec, certain parameters, the session owner, the session name, things like that. So how do they penetrate the VoIP SIP-based networks that lead to fraud? In a lot of cases, what we've observed in the networks that we're monitoring is you'll have a user agent that registers in a network with a user agent software such as iBeam, which is one of the most common user agent clients, soft clients that are used to perpetrate these networks. What they'll do is they'll mask credentials of an enterprise IPPX using a valid user agent name like Adtran or Polycom or Cisco. But what they can't hide is the actual session name that is down below in the session description packet layer. And most SBCs, it's not that they can't see this, they're not looking for it. You actually have to put in the exact string to look for where, fortunately on the RedShift side, we'll just put in, for example, like an EYE asterisk, because they've learned to manipulate different portions of the name, but they can't hide all of it. So once they're able to mask the credentials of an IPPX and actually register with a valid user agent, that's where they place large amounts of high calls to high-cost international destinations and/or domestic traffic pumping. So what will happen is, this is an example of where an iBeam has registered successfully in a network. So they'll send, the registration credentials. I have them marked out from because it's from a customer site, but basically it's from a user to a user. They're sending a register message in, and the user agent is an iBeam. And in this case, the registration was okay. So with that valid, registration, now this user agent that's compromised this user number can and will start to make high volume calls to international revenue sharing destinations. So one of the things that RedShift brings to the table is we're able to look at and define what are these different malicious user agents. And in most service provider networks, they'll identify what is allowed in their network, and then we'll just add a list of what user agents are not allowed. And so once this alert is detected where a malicious user agent, where the name is actually, like IBeam or VAC-SIP user agent or PB Extra or things like that, the RedShift UCTM application will notify or create an alert, and in some cases we can notify a piece of software middleware to take action. We have several of our customers that use the Blacklist API to be able to use the data in the alert to be able to update an ACL in the router if it's a security event, and be able to block that source IP and port number in real time, thus preventing fraud. And the ability to pick up malicious user agents, we're constantly seeing this in today's SIP VoIP-based networks. One example, and this is where they're actually hiding, they're spoofing the user agent name. So this is an example of the user agent is an AdTran total access, which looks like, a valid version number, generation number, what have you, and that's what gets past the SBC. But further down in the session description protocol, you'll see that the session name is PPL SIP, and that's another user agent soft client that is able to, they can use that to be able to manipulate certain parameters, but what they can't hide is the session name, and that's what we're looking for. Another example, same thing, is where the user agent, this one is using an IBeam user agent client, but it puts in what sounds like, a valid Polycom SoundPoint IP450 user agent name, but they can't hide the session name. And again, that's where we're picking it up. And whenever we see this in networks, 99% of the time when we talk to the service provider, these types of calls that get past the SBC result in fraud. Same thing, when we see that malicious media session, one of the differences is that, we are going to notify the middleware of an event to take action, but there's two possibilities. If it's, on the outside and it's determined that, it's a malicious media session, however, it's coming from a source IP and port number that is also listed as either in the banned list or a malicious user agent, we're going to update the router in real time if the user is not registered in the network. And if they are registered in the network and now their number's been compromised, what we'll do is use that Blacklist API data to update the soft switch dial plan to restrict destination if the user is registered in the network, which directly prevents fraud to that premium rate destination. Every case of malicious media session manipulation can go undetected because the SBCs are not, unless they're looking for the exact string, they're not going to be able to see it. This is one of the latest methods that the attackers are using to get by the SBC defenses. In the event that they do get by the SBC defenses, one of the things that RedShift has deployed as a feature within the application is the ability to keep track of costs. And certainly because malicious activity leads directly to toll fraud, that's a cost service providers would rather not have. So what we've done is we're able to upload the carrier rate tables into our application and be able to keep track of their costs as they occur, and then be able to set configurable parameters, whatever their pain point is hey, if I see more than $25, for example, going to Jamaica or any international destination by a single user, I want to know about it. And so in this case, we're able to generate a cost-based alert and be able to use that if it's a high severity alert, put it into the blacklist, and be able to use that data to update the dial plan and the soft switch to be able to stop calls to that destination number or block it to that destination number. Okay, that's basically from a high level our webinar for today. We just wanted to be able to cover the different three types of forms: malicious user agents, endpoints, and media sessions, and how these attackers are using and manipulating the test software, SIP-P, IBeam, PPL SIP, different software packages that they can use to manipulate to get basically to create toll fraud and create revenue for themselves, and certainly a cost to the carrier providers.
Awesome, Tom. Thank you so much. If you go back a slide to some of those graphics, some of the questions that we have pertain to those graphics, and let me just read those out to you and give the audience your thoughts on these, okay? Mm-hmm. So the first question is, how prevalent is carrier VoIP fraud? Is it limited to only certain geographies, given your comment about, expensive destinations, or is it more prevalent than just certain geographies? And what are they, and are there things that customers should be looking out for?
Yeah, certainly. Well, it's certainly not prevalent to a specific geographical region. If you have a VoIP-based network that's using the SIP protocol, regardless of where you're located, you're getting, scanned by these, by these SIP botnets that basically are sending option messages out at different networks. And what they're looking for is a valid error response, a 404 or a 403. That lets the attacking entity know that they've identified a valid SIP network. And then they start attacking it differently. So geographically, it doesn't matter. If it's a SIP-based protocol, VoIP network, it is going to get scanned and it will get attacked in one way, shape, or form.
So since it's exposed, it's able to be scanned, obviously, right?
Exactly. And every public-facing side of an SBC is exposed to the internet. And so what will happen is and these botnets that are sitting in data centers around the world are just constantly scanning every IP address that's out there. And what they're looking for is a valid response. And once they do, then they start attacking that network differently.
It's like the old E.T. Movie, Phone Home.
Right.
So somebody's there, phone home. Second question around security is actually around access control risks, or ACLs. Don't the ACLs that carriers already have of either routers, firewalls, even the SBC to some extent, block malicious entries? Wouldn't it block that? And if not, why not?
Well, first off, they don't know that it's a malicious entry or not. They just know that an ACL is nothing more. An access control list is a table that has either allowable IP addresses and port numbers or blocked IP addresses and port numbers. So the SBC doesn't know why they're blocking a specific IP address or port number. They just know that if it's in the table, it's going to be blocked. And when an ACL is updated, it's updated with originating IP address and port number, but again, they don't know why it's being blocked. That's where the advantage RedShift brings to the table is telling you why it's being detected and why it should be blocked.
Interesting. So when we talk about why things are going to be blocked, doesn't the SBC or soft switch have security safeguards that can block malicious media session attempts like the ones we're talking about, other than the access control lists that are kind of inherent to the SBC? And I guess how are hackers bypassing that? And given that they are bypassing it, what's unique about RedShift's ability to pick up on that?
So currently, right now, the SBC, unless they have the exact string that might be in the session name, they are currently unable to see it. You would have to actually put in the exact string for the SBC to look for. And to try to manage that becomes, unmanageable. We're able to put in wildcard characters and things like that to make it much easier to look at every SIP parameter, and that's part of our patents is being able to dissect and look at, via deep packet inspection, looking at every SIP message within the message set.
So it's almost like a vaccine you would get at the doctor, and it looks at mutations as well, yes?
Exactly. So, like, for example, I just saw on a customer system yesterday where, again, it's an IBEAM client, but they're manipulating the user agent name to, it was called PBXtra, PBX in capital with TRA in small letters, so PBXtra, and then followed by IBEAM version stamp, whatever, so it looked valid to a SBC, but if they weren't looking all the way down that string to see the word IBEAM, they wouldn't be able to detect it, and that call would get passed through to the soft switch and processed.
Wow, that would be bad. So talk about mutations. Are malicious media sessions an evolution of a prior generation of SIP and voice TAC varietals? And if so, which ones? So people can be on the lookout for not just the newest mutation, but other areas that they should be thinking about.
Well, it really depends on the attacking entities and how sophisticated or programmable the software or the user agent software that they're using to be able to allow to manipulate. If they can manipulate any parameter within the message set, then it becomes more difficult to detect. But at the end of the day, this is, one of the reasons why we built in the cost-based thresholds is if something does get through where either RedShift hasn't detected or there isn't anything malicious within the invite. And again, I have seen that coming in from TDM networks across the SIP gateway where everything within the message set is fine. And so there is no, quote, malicious activity. However, by keeping track of costs as they occur, as it turned out, it was a hacked PBX on the TDM side of the network, but everything looked valid coming into the SIP network. But the customer was able to protect themselves by keeping track of costs and having cost-based alerts set. So there are cases where, everything does look normal and everything is compliant with the SIP message set. But that's where this, either a volume or duration-based thresholds can be used. But certainly cost-based thresholds can allow the service provider to determine their level of pain. So when a cost-based alert is raised, if it's a $25 alert, boom, it's mitigated at that point, reducing any further costs that could have occurred if you weren't monitoring that type of activity.
So I like the dynamic costing. That's a good answer, because it isn't just about the quote unquote security break and the alerts that you get from security break, but what people really care about is, hey, we're spending a lot more money here than we usually do, and that should be quote unquote a red flag that something is wrong. And essentially you're saying, yeah, that is essentially the flag that's dynamically set.
Exactly.
So last question I have today is, what are the portions of the SIP message are possibly vulnerable? Why and what can be done proactively to safeguard those portions of the exposed SIP message anywhere during the VoIP life cycle, right? If you look at a call setup, a call itself, call teardown, what sessions or what portions of SIP could be possibly vulnerable?
Well, again, just like I previously stated, depending on the complexity or the sophistication of the user agent software that the attackers are using, and depending on how savvy they are, there's certain codecs that could be manipulated that aren't being looked at, for normal call processing. So it really depends on how sophisticated these attackers get and their ability to manipulate certain parameters. And it really just depends on, how that comes along, what parameters can affect, what can they do to get by, existing defenses. And so right now, that was the reason of this shout out webinar was just to look at how they're spoofing, the message set to be able to get by the existing defenses. And if they come up with a new way tomorrow, we're constantly looking at vulnerabilities and endpoints and vendor equipment and vulnerabilities and things like that to try to stay ahead of the game. And in most cases, it'll take an event where a service provider will report a problem to us. We'll look at it and certainly see, they're messing with, for example, a different codec name. They're putting something in that's causing problems in the network, not necessarily may not be leading to toll fraud, but causing equipment problems that eventually brings networks down or causes congestion in the network and things like that. So it really as they get more sophisticated and reports are reported to us, our task is to try to keep up with that and be able to quickly manipulate or look for different parameters within a message set that are being exploited.
Yeah, the unexpected downtime, I would imagine, would be a really bad thing, especially if you're a carrier who's stressing 5.9 reliability. That unexpected downtime can be very costly from a service level agreement and also just customer churn point of view.
Right, exactly.
So what about the last one I want to bring up is, we've talked all about these things, and you've talked about RedShift a little bit. And how does this feed back into the SIP threat intelligence that's updated across all the different customer sets? So once RedShift learns something about this, how is this able to be kind of propagated back to the customer set?
We can use what's known built into the application as receive blacklist updates. So we can push updates from our data center out to existing UCTMs. If they're pre-configured to receive that update, we can push out the latest signatures. Certainly any software update is going to contain the latest exploits and vulnerabilities and signature updates that we've learned through, our deployments worldwide. And so they'll either be pushed out as they're collected and determined, depending on how aggressive that attacker is. If they're just sending basic protocol messages with some invalid parameters like a fuzzing attack, but it's not doing anything to the network, then the level of paying attention to it is not as much. But certainly if they're starting to hit your SBCs with registration storm requests and they're trying to bring it down to its knees, then you want to be able to have a tool like RedShift that gives you that complete visibility into the SIP VoIP network, and being able to survey when bad things start to occur, being able to alert on that, and being able, having the service provider being able to take action either in real time or near real time, depending on how they have the system set up.
Yeah, I was going to get at the real-time threat intelligence thing. I know that's been very important in a data world, and a lot of people on the firewall side have a real-time threat intelligence module, or kind of an ability to create those signatures kind of on demand. And I think that a very important point for carriers is if they set this to automatic update, as you get updates that would defeat this type of attack, to be able to get those type of updates, I think would be very important to carriers, because they're not going to have the people standing by 24/7 to administer an update. And this way, the real-time threat intelligence for unified communication threat management can in fact be updated and defeat some of these and others, right? I mean, we're going to have future chat-out webinars about other areas that our customers are seeing. And the whole point is to give them the ability to get those updates as they need them, not just as they're around to administer them.
Exactly. And it's certainly a full-time job keeping up with them, that's for sure.
Yeah, definitely. All right, Tom, I really appreciate your time today. Let me just look one last thing to see if there's any other questions that we have here. No, I do not see any other questions. So I'll end today's session here. Please do go to redshift.com and register for future shout-out newsletters and webinars at redshiftnetworks.com. And we'll place this one on demand on the Redshift YouTube channel later today. And I thank everybody else for joining. And I'll end the recording of today's session now. Thank you very much, Tom.
Thanks, Adam. Much appreciated.
Okay.